Okay, good morning, good afternoon, good evening. Um, Welcome back to another coding notes every day until I get a job. This is day 137. Sorry, I've been gone for a week. There's just been a lot of stuff. So let's just continue to the week 5. And after week 5, I think I want to do some JavaScript DSA, like specifically for the DSA JavaScript, and just be much better. So I could probably find some YouTube or anywhere that shows good DSA, but for specifically JavaScript. Hello Yahoo, how are you? Sorry. Yeah, okay, so data structures.
All right, this is CS50, and this is already week 5. This is our last week on C, and it's also reputed generally to be the most challenging, perhaps, of weeks whereby we sort of climax with the material we've been exploring thus far. Sort of metaphorically, it's like we've been going up this hill, and I know it's felt like a lift each and every step, but now things kind of plateau out, I dare say. And even though it's not going to feel like we're suddenly going downhill or things get markedly easy, I do think you'll be able to catch your breath and start to apply a lot of the lessons learned over the past few weeks to everything that lies ahead. And among the things that lie ahead are exactly these data structures, which we've only touched on briefly so far. We had this look at arrays way back in week 2 already, and we've used those in a few different ways. But arrays are a super simple data structure. Data structure meaning it's a way to structure your data in the computer's memory, insofar as they have to be generally the same data type, but most importantly, back to back to back. And the catch with arrays, recall, is that you have to decide in advance how big the array is going to be. Do you want size 3? Do you want size 30, 300? But you do indeed have to decide in advance. But there's other things in life, not only the virtual world, but the real world, that we might consider a bit more abstractly. And in fact, you're going to start to notice after today, ideally, that the world is filled also with abstract data
Hello,
types,
hello,
whereby these
Gorilla
are ways of
Human.
structuring information, but that
Did
don't
you change
depend
your
necessarily on
profile?
the underlying implementation details. That is to say, you can implement certain features in life, in code, but there's bunches of different ways to actually implement them at a lower level, whether it's using arrays or, in fact, as we'll see today, other data structures as well. So while data structures are something very concrete, involving variables and pointers and functions and the like, abstract data types are a little more broadly descriptive. For instance, there are in the world these things called queues. Turns out there's things in the computer world called queues too, but in the real world, a queue is like what? Where might you see queues in the real world?
In the
ATM,
ATM.
okay, because they're typically called this there. So, like
When
lines in a
you're,
movie theater,
yeah,
lining up for dinner or
when you're
lunch,
buying
right?
something in the
Lines,
Christmas
queues.
market,
Now, queues have some kind of
the
role
Weihnachtsmarkt,
for people, but
lining up,
certainly in the
queues.
virtual world, you might have queues as well. In fact, this isn't as common nomenclature anymore, but if you're printing a bunch of things to a printer, those documents are generally stored in a queue so that they all print out in that precise order. And we can actually see this in the real world. So we wonderfully have 3 brave volunteers, if you 3 wouldn't mind coming on up. First up, we have here, come on over here, if you'd like to introduce yourself to the world.
Hi everyone, my name is Akshay and I'm a freshman in Canada.
Welcome, and if Akshay, you want to line up first right over here in the center of stage.
Hi everyone, I'm Jeffrey and I'm a freshman in Thayer, which is better than Canada.
Okay, welcome. If you'd like to line up in
Yo,
second place,
what
please.
does this guys do, bro?
I'm Jack. I'm a freshman in Matthews, which, as Professor Malin would agree, is the best freshman house.
Okay, yes, thank you. Matthew,
Yo.
over there. Okay, wonderful. Go ahead and hop in third place behind there. So these guys have formed what I would argue is a queue. They've sort of lined up
Oh shit.
in order
Which one? Man, sorry. I'm sorry, man. I didn't check Discord in a while, and I think
if I hand these out in the order in which they kindly volunteered, we have 1 thank you here, thanks very much. We have 2 thank yous here, thank you very much, and 3 thank yous. Maybe a round of applause for how easy that was for our volunteers. So it's sort of equitable all around, and notice that the queue actually, if we kind of geek out about this, actually had some operations associated with it, and I dare say we could somehow implement it in code as well. So a queue, or a line in the real world as we know it, is actually an example of a FIFO data type. First in,
FIFO.
first out. So that's sort of a property of this structure, no matter how you implement it, that describes sort of the equity of how you put the data in and get it out, or in this case, the human volunteers. The first one to line up at the front there, Akshay, got his prize first because he was indeed first in line, and then the second person, and the third person. So not all that interesting. You would kind of hope or expect that that's how life works when people line up or queue, but let's make this now a little more granular in the world of coding. So if you were to implement that same structure in code, be it
Hey,
printer
thank you,
or
man.
some kind
No
of
worries.
master type
Thank you.
scenario where you want to ensure a FIFO property, you would generally have 2 functions or 2 fundamental operations: enqueue, which means to put someone into the queue, and dequeue, which means the opposite, to take someone out. And just as FIFO implies, like the first in is the first one enqueued, but they're also the first one out to be dequeued.
Roger that, man. Thank you.
Now, how could we make this in code? Well, if we suppose for the sake of discussion that you want to have a queue, like a line, that can fit 50 50 things or 50 people in total, a capacity of 50, we could declare an int and make it a const so it can't actually change and initialize that to 50. And then we could use that elsewhere in our code, and we could create our own structure using typedef as well that includes this many people in an array called exactly that, people, each one of whom is of type person. So recall from weeks past, we used the struct keyword already, we used the typedef keyword already to invent our own data type called person. So let's just assume for the moment that now exists. But notice that you can actually encapsulate data types inside of data types even if you've made both yourself. So the world starts to get more interesting when you structure things in this way. But I also have inside of
Hello,
this
hello.
struct, which indeed I'm going to call a queue in code, also size. Why is it that I need to keep track of the total capacity of a queue in code, but also apparently I constantly have to keep track of the size of the queue? It's a subtle difference, but these two words mean something very distinct. Capacity is and always will be 50 because it's a const. But size is different how? Just intuitively, yeah. Yeah, so size is going to be the current number of people or things in the queue, and it stands to reason that you've got to keep track of both, because otherwise you might have like 50 garbage values in memory. If you want to keep track of how many of those values are valid and represent, in this case, persons or people, well, you need to know if there's 0 people there, or 1, or 49, or 50, or anywhere in between. So this is how we might, in code, and we won't go down this road further, how we might in C code implement the idea of a queue using familiar syntax by kind of layering some of these ideas we've seen already. All right, but it turns out you don't always want queues, and you specifically don't always want FIFO. So there also exist in the world these things called stacks. For instance, if playfully I propose that I actually do own different colored clothes, in fact, I've got like a red sweater, I've got a blue sweater, but if at home in my drawer or closet, I store all of my sweaters in literally a stack, like this one here, well, it stands to reason that if I'm doing sort of laundry frequently enough, I might wear this on Monday, this on Tuesday, this on Wednesday, then I might do a load of laundry, and so there they're back on top of the stack, and I never actually get to the bottom of the stack here. So this is a very different operation. It's not equitable in the same way our queue was, because it would seem that the last sweater I put in is going to be the first sweater I take out. Now, this sort of stands to reason that that's obviously how the real world works when you stack clothes together, but these things called stacks are everywhere too. Like in the dining hall, in Annenberg Hall, there's a whole bunch of trays, presumably, and unless the dining hall is really busy, there could be one really dirty, nasty tray at the very bottom of the stack that never gets used because people are constantly taking the ones higher up until they finally refresh them and clean them.
Push places something on top. Pop is removing something from the top.
A stack in and of itself. Why? Because when you get new mails, where do they typically visually end up? Well, sort of at the top, at the top, at the top. And if you're like me, if you get lots of emails that you don't really necessarily get to all of them, you might reply to someone who wrote you most recently and completely blow off someone who wrote you earlier because they've been pushed further and further down, so to speak, in the stack. So these data structures, or these rather data types, are really everywhere. And stacks, therefore, suffice it to say, are not FIFO, first in, first out. They're what the world calls LIFO.
LIFO.
First out, because the last sweater into the stack is the first one that I actually pull back. And so we can see this even more clearly with 3 more volunteers. If you 3 wouldn't mind coming on up, exhibiting a LIFO property here. If you want to introduce yourselves one at a time. Here we go.
Hi, my name is Michelle, and I'm a freshman in Greeno.
Welcome, Michelle. If you want to come over here first by the table.
Hi, my name is Sophie, and I'm also a freshman in Greeno.
All right, Sophie, if you want to come over here.
Hi, I'm Alex. I'm a freshman in Wigglesworth.
Wigglesworth, nice. Wigglesworth, nice. If you want to come in front here. So these 3 have clearly stacked themselves into exactly this data structure, a stack, which is actually too bad because I only have like 2 prizes this time. So I think I can offer you your prize, and we can offer you your prize, and unfortunately we can just give you a round of applause because you were the first one into the stack. Okay. All right, we actually have a third, but point is hopefully made, so thank you to these 3 volunteers. That's all we needed you for. But a LIFO, then, is a data type that indeed has that property, which you might want in some context, like your Gmail inbox. You might kind of have to tolerate in the physical world just because of gravity and how closets and drawers work, but it isn't necessarily a property that you want of all data types, for instance. Case in point, in the world of printers, it would be kind of obnoxious if a lot of people in an office or university are printing to a common shared printer, but only the person who printed most recently is the one that gets their document first. So you'll see in the real world not only queues, but potentially stacks, especially when things maybe get unfair when you're in a store and the cashier isn't necessarily honoring the first in, first out property. But as for operations, these two have
Push and pops.
So instead of enqueue and dequeue, in the world of stacks, we actually generally say push, which means to push something on top of the stack, and pop, which means to remove something from the top of the stack. But top of the stack is the operative word. You're not sort of sliding the blue sweater out from under everything else. You're only operating at the top of the data structure. But it turns out if we think now about stacks as being this abstract idea that have these operations associated with them, in code we could actually implement them pretty much the same. So notice here, the only difference on this screen
Just
here
the
is
name.
we're calling this structure a stack, but the stack still has some capacity, it still has some size.
Yeah.
Sort of imagine in your mind's eye how a stack differs in code from a queue. Whatever loop you're using, whatever conditionals you're using, you're probably removing things from a stack from a different part of the array than you would from a queue. So if you just imagine, maybe you start removing things from the front instead of the back. At the end of the day, you can implement these abstract types using similar code here, but you're going to have to tweak the operations to give the property that you want FIFO or LIFO. So again, the overarching goal of just introducing stacks and queues at this point is that there is this distinction between an abstract data type, like some way of organizing information that has certain properties, certain operations, but you don't necessarily need to know or care how it's implemented in code, because clearly you can implement it one way or the other, and the actual data structures with which you are building those abstractions. So one's high level, one's low level. And indeed, that's the whole purpose of abstraction. So our friend Professor Shannon Duvall at Elon University actually brought this same idea to life with a short video in which Jack learns the facts about queues and stacks. So we thought for a moment to hammer this home, would dim the lights and hit play on this short film.
Once upon a time, there was a guy named
Oh my
Jack.
God.
When it came to making friends, Jack did not have the knack. So Jack went to talk to the most popular guy he knew. He went up to Lou and asked, "What do I do?"
He didn't have a
Lou's
what?
face was really distressed. "Well," Lou began, "just look how you're dressed. Don't you have any clothes with a different look?" "Yes," said Jack, "I sure do. Come to my house and I'll show them to you." So they went off to Jack's, and Jack showed Lou the box, where he kept all his shirts and his pants and his socks. Lou said, "I see you have all your clothes in a pile. Why don't you wear some others once in a while?" Jack said, "Well, when I remove clothes and socks, I wash them and put them away in the box. Then comes the next morning, and up I hop. I go to the box and get my clothes off the top." Lou quickly realized the problem with Jack. He kept clothes, CDs, and books in a stack. When he reached for something to read or to wear, he chose the top book or underwear. Then when he was done, he would put it right back. Back it would go, on top of the stack. "I know the solution," said a triumphant Lou. "You need to learn to start using a queue." Lou took Jack's clothes and hung them in the closet, and when he had emptied the box, he just tossed it. Then he said, "Now, Jack,
What?
at the end of the day, put your clothes on the left when you put them away. Then tomorrow morning, when you see the sun shine, get your clothes from the right, from the end of the line. Don't you see," said Lou, "it will be so nice. You'll wear everything once before you wear something twice."
This is
And with
a
everything
queue,
organized
right?
in his closet on
Yeah.
the shelf, Jack started to feel quite sure of himself, all thanks to Lou and his wonderful queue.
Wow.
All right,
Very
so
nice.
hopefully now that reinforces really what these stacks and
Yeah,
queues are.
that's
Let's actually
pretty
transition now to building
understandable.
on top of where we started in week 2 with arrays, and really reach a peak today of sophistication when it comes to using last week's concept, that of pointers, to kind of stitch together in a computer's memory really any kind of structure that we want. But recall first that arrays indeed had this key property that everything was contiguous, back to back to back. So for instance, if in week 2 onward, we wanted to store like 3 integers in memory, it might look abstractly a little something like this, where we might put 1 and 2 and 3. But the catch with arrays, recall, is that you have to decide in advance, as per those square brackets, like how big the thing is going to be. And so if you decide in advance with square brackets that you want an array of size 3, but later you realize, oh darn, I want to have a 4th integer or a 5th one, you might have actually metaphorically painted yourself into a corner. Ideally, you would put the number 4, for instance, right here. But again, in the context of the computer's whole memory per last week, there's other stuff going on. So for instance, these might not necessarily all be freely available to use, because if you've got 1, 2, 3, multiple variables and lots of functions in your program, well, these other memory locations might be filled with actual values and as well as garbage values. So as per Oscar the Grouch here, assume that anything with him just represents a garbage value.
Sorry, I want to put them in, but waiting for it.
We're sure we can use that location in memory, but there might actually be valid strings like hello, comma, world, \0. And I've kind of graded out because it's separate from the 1, the 2, and the 3, but there could be another variable in your program that's storing hello world, and just by chance, because you created that variable after the array, you ended up with an H immediately after the 3. So it would seem that you've indeed painted yourself into this corner in that unless you sacrifice that H and wreck that whole string, there's no room for the 4. But is there? I mean, obviously, there's a lot of room for the number 4, not to mention the 1, the 2, and the 3, because all of those garbage values don't mean you have to respect them. You can reuse those locations. They're garbage in the sense that you use them already, but you're no longer using them. So I could put this 1, 2, 3, and 4 somewhere up here, somewhere here, maybe even somewhere down here. So how could I then accept the fact that I do want to grow this array? Well, I could just say, fine, I'm going to have to sort of bite my lip and just copy the 1, the 2, the 3 to a brand new location that actually has room for a 4th value as well. And we can put the 1, the 2, the 3, and we can now have room for the 4, and then we can get rid of the original array somehow. So this is a solvable problem, even though we haven't had to do it in code yet. But what's a downside of this solution to growing an array, to store more data after you first create it?
It's not dynamic, right?
More, well, it's
Yeah.
more space in a good way
But
at the moment. I think it's not so much space that we're worried about here. Sorry? Yeah, you have to keep doing this again and again. So if I can put words in your mouth, it takes more time, because now just to insert one value like the number 4, instead of just jumping to a free location and putting it there in constant time, I kind of have to incur linear time to copy the original array into a slightly bigger array and then add that
I
new fourth
see.
value. So you're just kind of wasting your own time. Now there's a potential alternative. What could we do? Well, I could have just allocated.
Sorry, don't bring your mic closer because the volume difference is too high. Oh, is it like okay. This is okay, right? This is not too far and not too close. This distance.
More space than I need from the get-go. So even though I asked the compiler for 3 integers, maybe it could be a little generous and just give me 4 secretly, or 5, or 500, or heck 5,000, so that I never deal with this problem in the future. That way everything would be super fast because I never have to waste time moving things. But what would be the downside of that approach? Sort of
Wasting memory. Yeah.
For an array.
Wasting memory.
So it's a waste of space. I mean, there's only a finite amount of memory in your Mac, your PC, your phone. Why are you going to write code that's sort of designed intentionally that way, but arguably poorly designed, because you're just throwing memory away that no one can actually use, none of your other programs or apps can actually use, because you just want to make sure you can grow this array in case you ever need it. So that too doesn't really feel like a compelling trade-off. But here is really a theme now that we'll see really throughout the semester and throughout computing. There's always going to be some trade-off, and it's very often between time and space. But as we've discussed in the past, it might be a trade-off between the complexity of your code. I mean, honestly, imagine in your mind the sort of for loop or the while loop that now you have to write code for to copy all of that from old to new array. Like, that's added complexity. We're wasting my human time. We're introducing more lines of code that increases theoretically the probability that one of them has a bug. So there's just lots of trade-offs of solving problems in this or really any other way. So what might we do? Well, what if we could structure our data a little more intelligently? Rather than just use this super simple data structure called an array, where everything has to be back and back and back, could we instead sort of treat the computer's memory kind of like a canvas, such that if there's free space over here, fine, I'm going to put something over here. If there's free space over here, fine, I'm going to put it over here. Can I just then stitch these things together somehow? And I'm using that word deliberately because last week we saw pointers, which are just addresses, but maybe I can sort of metaphorically, and as per the arrows I drew on the screen last week, maybe I can just kind of connect the locations in memory that are available so that I no longer need to care if my data is back to back to back in memory. I can just sort of follow arrows from one piece of data to another. And all we need for this is some mostly familiar syntax. One, we have struct, which is the keyword with which we can create a structure, our own data type, along with typedef. There's dot, which we haven't used that much, but we did see a while back, whereby using the dot operator, you can go inside of a structure to get at the name or the number field, for instance, in a person. And then, of course, we spent last week really focused on the star operator, so the asterisk, whereby you can use pointers in some way. So using just these 3, we can actually build most anything we want structurally in our computer's memory. And in fact, the only new piece of syntax today is going to be this, an arrow, which is just a hyphen and a greater than sign, which, as we'll see, is the exact same thing of using a period and a star together. We'll see what that means in just a bit. So how can we go about implementing an alternative to arrays that actually allows us to grow and even shrink them if we want, without having to move everything that already exists in memory around in some way? Well, let's see where we might begin with arrays alone. Let me go ahead and create a file called list.c. And in list.c, let's include standard io.h at the top. Let's declare int main with no command line.
Stable volume. Keep the volume under this range. Yeah.
An array called list
I guess
of size 3.
maybe if it's like a bit too close, but if not, then I think it's all good.
1 at the location 1, the number 2, and at location 2, the number 3. So even though the array recall is 0 indexed, I'm going to use some human numbers like 1, 2, and 3 in sequence like this. And then let's just do something mildly interesting like for int I equals 0, I less than 3, I plus plus, and then inside of my loop, let's just print out those numbers just to make sure that they are printing as I would expect. All right, so if I scroll up to the top of this code, there's not all that much going on other than I'm creating an array of size 3 with the numbers 1, 2, 3, and then I'm printing them out with a simple loop. All right, let's do make list. So far, so good. /list, and there we go. 1, 2, and 3. All right, so that works perfectly fine so far, but let's actually see what would be involved if we are using arrays alone to grow and shrink this array. So let me go back into my same program. Let me throw pretty much all of this array away for the moment, and let me propose that we're going to create the array in a different way, in a way that we haven't done before. I'm going to say int star list equals the return value of malloc, whereby I want 3 times the size of an int. So I've not actually created, in class at least, an array in this way, but if an array is just a sequence of values, contiguous in memory, and malloc, we saw last week, is just a function that gives you a chunk of contiguous memory, I could kind of do things the old-fashioned way and use malloc to give myself a chunk of memory and then treat the first part of it as space for an int, the second part as space for another int, the third part as space for a third int. I'm just kind of doing things at a lower conceptual level. Of course, to use malloc, we needed to include last week standard lib.h, so that gives me access to that. And recall that sometimes things can go wrong. What does malloc return if there's no memory available?
Null.
Null, so null, two L's in the context of memory. So if this list value happens to equal null, well, there's nothing interesting to do here. Let's just return 1 and exit the program altogether.
I know we have the code here, but I kind of want to try
get back a chunk of memory that's big enough for
follow.
3 integers based on whatever their size is on the computer I'm using. So let's now initialize this array. List bracket 0 gets 1, list bracket 1 gets 2, and list bracket 2 gets 3. So just as before, I'm initializing it in the same way. But now, let's suppose that time passes, and I decide that, oh, darn it, I really wish I had allocated space for a 4th integer. Now, obviously, I can just change this code quickly, but let's assume that this is a much more complicated program. It's running all the time, and maybe it's up to the user to say when they are ready to give me a 4th integer. So this is a simplification, but at this point in my story, after some time has passed, let me propose that, oh, darn it, I painted myself into that corner. Let's reallocate a new array that's a little bigger. Well, how can I do that? Well, let me go ahead and temporarily give myself a variable called temp, TMP for short, set that equal to the return value of malloc, whereby I'm asking now for 4 times the size of an int. So I'm just sort of changing my mind later on in this program. I actually want an array of size 4. Okay, I still have to check that nothing went wrong. So if temp equals null, then let's go ahead and return 1. Then let me go ahead and copy everything from the old array into the new array. So how do I do that? Well, I can do 4 int I equals 0, I less than 3, I plus plus, just like I was printing the thing out earlier. And I can say, put into the temporary array at location I, whatever is in the original array at location I as well. So this is kind of like the string copying program we wrote last week, where I did everything manually by copying one into the other. Now I'm just doing it more generically for integers into arrays. Then if I want to go ahead and add a 4th number to this array, I can literally do temp bracket 3 gets 4, and I'm saying gets to mean assignment here, and that's just adding now the 4th value to the array, just like I did a moment ago by plopping the 4 into the bigger chunk of memory. All right, I'm almost done here, but I do need to do some cleanup. After I have created this new array of size 4, I don't think I need the original array of size 3. So recall from last week, I can free the original list, and that just hands it back to the operating system. And then if I want to keep this new chunk of memory around, you know what? I'd rather call it list instead of temp. So because both of those are just variables, I can simply say list equals temp. And this just sort of renames that new bigger chunk of memory to be the actual list that I care about, so that moving forward in this program,
We
I
can just use list.
that array
Yeah.
instead of the original. And heck, if I want to now print this thing out, I can do 4 int I equals 0, I is less than 4, I plus plus, and then inside of this loop, I can print out using printf and %i \n, whatever is at list bracket I, which can now go up to index 4. Not through, but up to index 4, because there's 4 possibilities there. And then at the very end of this program, I should probably be a good citizen, so maybe time passes again, but eventually I should free that list itself. I already freed the temporary, the original list. Now I want to free the new, bigger list as well, and now I can just return successfully 0. All right, if I didn't mess this up, let me open my terminal, do make list again, /list, and I should see 1, 2, 3, 4. And I think this is now correct, but notice that just to make this simple idea, 44 lines of code just to make an array slightly bigger, if you will. And there's actually a subtle bug. This is super subtle, but it's the kind of thing you need to start thinking about whenever you're manipulating memory, and I'll call this one out myself. So notice that at the very beginning of this program, when I initialized space for 3 integers, I realized something could go wrong because list could be null, and okay, I'm going to exit immediately by returning 1. But there's another subtlety here which I didn't fix yet, and Valgrind eventually might catch this for me. Notice here, I again use malloc, and I did realize here, oh shoot, something could go wrong, and malloc could again here return null, so I do check for that. But notice that I return before cleaning up the memory that I already asked for. So this is super subtle, but what I should really do at this second use of malloc is if I didn't have a valid return value for malloc, that's fine, but I had better free the successful value of malloc that I got earlier. Otherwise, this is the definition of a memory leak. If you've allocated memory here, you're exiting your program here, but you never actually give this memory back, that's a memory leak. And to be fair, the operating system will eventually reclaim that memory for you, but if we use this as sort of a working principle, you should always, always, always free memory that you yourself have allocated, whether it's in cases of error like this or intentionally like down here. All right, let me go ahead and just make sure I didn't break anything. Make list, dot slash list, and voila, we have now 1, 2, 3, and 4. All right, so let me propose that this is not actually as annoying as it needs to be when you want to grow a list of size 3 into a list that's slightly bigger of size 4. There's actually one other function we can introduce today that will make our lives a little easier. Let me go back to VS Code, hide my terminal window, and let me propose that what we could do is actually this. After some time has passed inside of main, instead of allocating a brand new array like this of size 4, we can actually do this instead. We can use a function that we've not seen before called realloc and just ask really C to do the reallocation for me. And this is nice because what C is going to do is if we get lucky and it is not the case that we painted ourselves into a corner, so to speak, and there's no hello world right after the 1, 2, 3, realloc is going to be smart. And if it can leave the 1, the 2, and the 3 in their current locations, but just give you a little more memory to the right of that array, so to speak, realloc is going to do exactly that and give you back the same chunk of, but a slightly bigger version of that memory. So you therefore do not need to move everything around in the computer's memory yourself. Now, in order for realloc to do all of that, we actually do need to tell it what the address is of that original chunk of memory. So unlike malloc, which takes only one argument, realloc actually takes 2. The first of which should indeed be the address of the chunk of memory that we are trying to resize. Now, just like malloc, realloc might also return null in the event that maybe not enough memory is available, so we still need to check for that return value, immediately freeing the original list and returning 1 as needed. But what we don't need anymore is this chunk of code here, wherein we were previously copying from the old chunk of memory to the new chunk of memory all of those values, because that too is among the features that realloc provides for us. But my God, I mean, still, like what? Now we're down to like 40 lines of code instead of 44. Like, that's not a huge gain. So is there perhaps a better way to go about this process of actually resizing arrays if and when we need more memory? And yes, now that we have access to pointers from last week, functions like malloc, now realloc, as well as free, we can actually build a memory structure, a data structure that doesn't
Linked
limit
list.
being moved around. We can leave everything where we put it in the first place by way of a structure called now a linked list. So what then is a linked list? Well, let me propose that a linked list is a list whereby you're just using pointers to link things together in the computer's memory. So for instance, if here is our canvas of memory, and there's a lot of places that things could end up in this story, suppose that I want to store the number 1 first, well, that location happens to be available, and so I plop the number 1 there. We know from last week that every byte in a computer can be uniquely addressed, just like this building is 45 Quincy Street. This is maybe byte number OX123, using last week's hexadecimal notation. Now suppose for the sake of discussion that maybe this space is being used, this space is being used, this space is being used, so there's no room at the moment immediately next to this number 1. That's okay. Why don't I go ahead and plop the number 2 where there is room, which is maybe over here. Maybe that location, for the sake of discussion, is OX456. Where do I put the 3? Well, maybe it ends up over here, and that happens to be location OX789. So no longer are these 3 integers contiguous, back to back to back. They're sort of all over the place in memory, but that's okay, because if I can somehow connect these dots by pointing one to the other, maybe I can kind of stitch together a data structure in the computer's memory. And I can if we use last week's building block of pointers. Let me waste a little bit of space by using another byte, or technically it might be as many as 8 more bytes. So this is not drawn to scale, but pointers, recall, typically take up 8 bytes or 64 bits nowadays, but I want to draw these things more cleanly as simple rectangles here. So here's still an int, here's still an int, here's still an int, but let me propose that if for every integer in this list, let me also allocate a pointer, and a pointer. So each one can point to another location. So what should this pointer point to? Well,
The
ideally,
address.
OX456. What should this one point to? Ideally, OX789. What should this point to? Well, if this is the end of the list, we need some kind of special sentinel value. And in the world of memory, like, what's the only sentinel value we've seen thus far?
No.
To signify the buck stops here, there's no more list. So null. So OX0 really. So just arbitrarily but universally, we decide to use 0 as a special address that just means there are no more numbers in this list, aka null, as we saw last week. Now, this is all fine and good, memory address, and we're stitching things together in this way, but you don't need to think at this low level. Recall from last week, we think of pointers as, for the sake of discussion like last week, you can think of pointers as really just pointing from one location to another, and so we can kind of abstract this away and just get rid of all of that and use some basic arrows instead. So how do we keep track of a linked list? Well, a linked list of numbers, well, we store the numbers themselves wherever there's space in memory. We use some extra pointers associated with each of those numbers to kind of link us from one to the other. And then the linked list itself, it turns out, we're going to spend one final pointer that just keeps track of where the start of, or the so-called head of the list begins in memory. So what's the upside here? Well, the problem I claim we have solved is we no longer need to have things contiguous, back to back in memory, which means we can make much more efficient use of memory because we don't need a huge chunk of memory to be available all contiguously. Especially if the program's running over time, you can just start plopping things wherever you have room. Now, for those familiar, that actually can lead to something called fragmentation of memory, where your data structure is kind of fragmented all over the place, but nowadays on modern systems, not really a big deal. And these pointers allow us to get from one location to another. But clearly, even in this picture alone, there is a downside. There is a cost for linking numbers together in this way with pointers. What is the downside of linking them together here? Twice as many? It looks like
Memory.
it's twice as much space, and it frankly might be a little bigger than that if these pointers are particularly large. You're spending space, but you're gaining the flexibility of no longer needing to copy everything from one smaller location to one bigger location. And if you've got lots going on in memory, you can actually use all available memory as opposed to telling the user, sorry, I've got a lot of bytes available, but some are here, some are here, some are here. I just don't have them all contiguous for you. That would be really obnoxious if the program can't proceed because you have enough memory, but it's not all in one place, and you don't want to spend linear time like shuffling everything around. list just gives you flexibility. You can use what memory is available, albeit at the cost of these pointers. So it's not a win-win, but it is a trade-off, depending on what feature is most important to you. All right, any questions on this here structure called the linked list thus far? Any questions at all? No? All right, so let's translate this to the simplest code that we can, and it's actually not all that different from some of the syntax we've seen. Here is how I might remember implementing a couple of weeks back now a person, whereby originally it was a string name and a string number. We took away those training wheels, and we revealed last week that it's char star name and char star number, but this is indeed as a person. But this allowed us, using struct and typedef together, to create a new structure in memory that encapsulated information we cared about, like a person's name and number. Well, let me propose today that we actually introduce a new term of art, node. It doesn't really have a technical definition as much as it is just a container for data in memory. So node is very common in graphs and other types of structures, but node is like a generic rectangle that stores some stuff for us. What could I put inside of this data structure in C to implement that concept of a rectangle with both a number and a pointer to another number? Well, I can literally say int number. So inside of every rectangle, aka node, is going to be an integer called number. And then this one's a little weird. I'm also going to store a pointer called next that points to another node. So we've not seen this word node before, but it's the same idea as char star. But instead of pointing to the address of a character, this variable next is going to point to the address of another node. And this is somewhat subtle and a little annoying, but because C reads code top to bottom, left to right, there's a bit of a gotcha here. I am not allowed to use the word node here if it only technically exists once I get to the final line of this code. So a little subtlety in C. There is a fix, though. I didn't need this for person, because persons did not involve linking things together in this way. But if I add the word node here, so it's a little more verbose, typedef struct node, then I can change this to struct node star as well. So now I've seen them top to bottom. This can stay the same. That's the solution to that problem. And this is how everyone does it in C. It's not always necessary, as with persons, but here you just need to mention a little more verbosely what is the name you're giving to this thing, so you can reuse it here from top to bottom. So what does this do for us? It just creates in code a definition for those yellow rectangles that we just drew onto the screen. How can we now actually use these? Well, let's take a look at the code via which we can start creating a linked list. Even though at a glance it might seem a little complicated, but it's going to build on exactly what we did last week. So let me go back to VS Code here. Let me actually get rid of pretty much everything we just did, effectively getting rid of our array-based implementation. At the top of my file, let me go ahead and create with typedef and struct and node exactly that data structure that has a number, and inside of that is a struct node star next, and then the name of this thing itself shall be more succinctly node. Just to be clear, we could call node anything we want. We could call it rectangle if that's simpler. We could call next anything we want. We could call it arrow. So these are just arbitrary but conventional choices to describe that yellow rectangle previously on the screen. All right. Now what do I do in my program to create a linked list that looks ultimately a little something like this? Well, first, I'm going to create a pointer that is of type node star called list and set it equal to null. What this means is that I have created on the screen over here the pointer at far left, a single pointer that's pointing to the beginning of this list, but I initialized it to null because there is no list of numbers just yet. All right, what do I then want to
Check, check. Hello. Sorry, I was on a call and I was a bit confusing. So for Mute, you have Python classes and objects, database concept, structured query language, Python and CSV, importing source program in Python, data manipulation to SQL. Hey, thank you. So you have a lot of stuff with the Python. Have you been practicing yourself, or like, are you doing anything? Like, what is your knowledge level as of right now? Because like, if you have the exam tomorrow, there's nothing pretty much you can. There's not a lot. Oh, sorry. How's like, what have you been learning so far, or like, sorry.
to do? well, let me just do something 3 times just for the sake of discussion. Let me do 4, int I equals 0, I less than 3, I plus plus. But in the real world, this should probably be more dynamic, and I don't just hard code the number 3. But what do I want to do? Well, if I want to achieve this picture, I think what I need to do is ultimately use malloc to create a node, put a number in there, and then do it again for another node, put a number in there, and then do it a 3rd time, put a number in there, and then somehow stitch these things together. So how
Sorry,
do I
sorry.
do
It was
Well,
a sudden. There's no transition.
to do it this way. Inside of this loop, because I want to do this 3 times in total, let me create a pointer called n for node, and set it equal to the return value of malloc, whereby I want enough memory to fit the size.
Damn, I don't have the get in. Do we have the get in? No, we do not. Okay, you know, it's fine.
Of a node. So I keep using size of so that the computer can just tell me how much memory I actually need for a node. Recall, as always, malloc returns the address of a chunk of memory. Hence, I must assign it to a pointer. But what is that chunk of memory going to represent? A node. So that's why now, today, I'm using node star instead of char star, because last week I wanted a string of memory, aka char star. This week I want a memory for a node instead. So otherwise, it's behaving the same way. Quick sanity check. So if n equals null, something bad has happened, and so I should just go ahead and return 1 at this point to signify error. And I'll come back to the issue of potentially leaking.
Okay, the arrow syntax thing, I'm
Here
still
now, I have the opportunity
don't
to actually go
understand.
into that chunk of memory and give it a number. So how do I do that? Well, recall that if n contains the address of a chunk of memory, just like s was the address of a string, if I want to go to that address, I can do star n. And that goes to the address, to the chunk of memory I just created. If I want to then go inside of that chunk of memory and access specifically something like the number field, as in my struct here, well, I can use the dot operator, which we used in the past. So my dot operator would allow me to do this. Dot number equals, and let's just use getInt to keep things simple today, even though that's from the CS50 library. I can go ahead and set that equal to whatever number the human types in. Now, syntactically, I need to make a little tweak here. Because of order of operations, I want to make super clear that I want to go to that address first, then go inside of that chunk of memory and set the number to whatever the human types in. Then I'm going to go to that same chunk of memory, a little redundantly. I'm going to change its next field to at least be some safe value that I know about, like null. I don't want it to be a garbage value. I want to just create this rectangle in memory and know that there's nothing there just yet.
So we know, okay.
What have I now built in memory? Let's do this a little more slowly, a little more methodically by visualizing what it is we've just built.
Yes,
so
please.
At the top of the screen here, we're going to see 1 line of code at a time, and on the bottom part of the screen, we're going to see what.
For a mute, there is a lot of topic, by the way. You have like Python OOP with the classes and objects, and then you have SQL with Python. So that's a little bit of data stuff. Python CSV, importing C. Okay, this one I don't know, the importing C++. But yeah, my data visualization user PIP, is it using PyPlot, I would assume? Because I have used PyPlot before. It's a, yeah, it's a like my matplotlib. It's a, oh, what is this? This one is a stable version. So switch to disable version. What do you mean? What? Okay. Yeah, I've used this for my thesis, basically creating a lot of this stuff. Such an interesting way. But yeah.
What I'm building in memory step by step.
For SQL, I actually was practicing using Bolt Bolt. Like this is for learning SQL, but I don't think that you could just do it in one night with the interactive tutorial. I think it's very interesting, and I think relearning it would be nice. But I was relearning SQL, I think, a few months ago on stream to kind of get the basics right again, making SQL.
The first line
Making like a database.
Give me a variable called list that eventually is going to point to this list. I don't like this though, because it means that it technically contains a garbage value right from the get-go. So who knows where this linked list is in memory? And that's why in my actual code I said no, let's not tolerate a garbage value there. Even though this does give me a variable called list, let's initialize that to null so that this isn't pointing to some random location. I'm just going to use blank to indicate that it's null. So this is how I might begin the story of creating this linked list. All right, what was my next line of code that I did? Well, I indeed used malloc to allocate enough memory for the size of a node. I claim that malloc always returns the address of that chunk of memory, so I stored it in a variable called n for short for node. So where is that on the screen? That's like getting a variable called n, whose value initially is a garbage value, as any variable is, but as soon as I call malloc, that's like giving me a rectangle of memory over here, and so I just have to change the number field and the next field to be the values I care about. So what did I do after this? Recall here that 1, after doing the assignment from right to left, that effectively means that n points to that chunk of memory. I could use OX123, OX456, but who cares? Let's just use arrows for now to keep things visually more simpler. So this variable n is pointing to that chunk of memory. Then I went to that address, following the arrow, and went inside of that structure. How did I do that? Star n dot number gets 1, and that's like actually changing the number 1 there. And it turns out there's actually a simplification of this. This is not pleasant looking code. It looks cryptic. You have to remember all of the symbols. I bet we could simplify it using that one new piece of syntax today.
Oh, okay. Wait. Let me write that down. This is gonna be confusing to a lot of things. So we would have, okay, let me go back to the code. Okay. It doesn't really have the version, the old version. This is like the latest newest one. So this allocates the no, this is creating the memory for numbers. It's this one. And then the malloc created this one, right? Created the empty memory setup for the node. And that node with the syntax. So okay. How should I? I'm gonna write the whole code in paper so that I would actually trying to, okay, never mind. Int void, because it doesn't return anything. We have a node, a type of node pointer for the empty one. And then we have a for loop. And this creates the allocation. Yeah, and then as always, a good citizen would check. Okay, why does this one use 2? And previously do we use 2 to always check a null? Yes. Sorry, check if null. If it's not a null, it's gonna return. Yeah, sorry, if it's null, it's gonna return 1. This is the old syntax, which is we take that node, we access the number, and we input the 1. Basically, this one is doing this. We have this, we have n, we have this number, and next.
All of the symbols. I bet we could simplify it using that one new piece of syntax today. The arrow operator that I showed on the screen earlier simply means do all of this with the parentheses and the star and the dot, but do it in a way that kind of reads more cleanly from left to right. And it kind of does. If this is n and you follow the arrow and you go to number, you get to exactly that location in memory. Start at n, follow the arrow, and voila, you are right at that location in memory for both number and next. So most people would actually use this syntax. So just to be consistent.
Wait, yeah, 1 moment. I want to make an announcement into the Discord so that we could signal if people want to join. Oh my god, there's 4 people watching. Hello, welcome. I hope everyone have a great Sunday and good luck with Monday. continues with CS50 week 5, week 5. And do we have anything in here? No. Memes? We have some memes. Oh my god, we have a meme on the channel? Nice. We should share more memes. Sorry, back to this.
Let me go back quickly to VS Code and just make that subtle change. Instead of parentheses, star, n dot, let's just say more simply, n arrow number, and down here, n arrow next. And that's kind of tightening up the code already. All right, what happens after this? Well, I should probably initialize this next pointer to be some known value so that it's not pointing at some garbage value still. How did I do this? N arrow next equals null, just as you saw a moment ago in VS Code. So Oscar goes away, and that's effectively null now. So this isn't complete. This is now really a newly allocated list of size 1, but notice we haven't updated the original list, so this is actually a step I haven't done yet in code. I think I want to set list equal to n, which sounds a little weird, but if n is an address and list should be an address, all I'm doing is copying whatever the memory address is here, ox something, into list, which is like duplicating the arrow and pointing it from left to right as well. And then heck, I don't need the temporary node anymore in my story because I've just created the first number in memory. So let's actually go back to VS Code for just a moment and add that final flourish at the bottom of this for loop. When I am ready to insert this node into the list, what I think I'm going to do is I'm going to say list equals n. The problem with this approach at the moment is that if I'm doing this in a loop, I am going to constantly update list to point to the very node I just allocated. So if we keep going through this loop 3 times, I'm going to create a node for 2, and then a node for 3. But based on that line of code, I'm always just going to point list at the most recently created node, and there's going to be no arrows linking the 3 to the 2 to the 1. And so I actually need to be a little more clever about this. And so in VS Code here, what I'm going to do at the bottom of this loop here is instead, I'm going to do the following. I'm going to specify that whatever n's next field is should actually be the same thing as the list. And then I'm going to say the list should point at n. So I technically don't need this line of code here anymore. What instead I'm going to do is this. If I go back to the picture over here, and I create now a second node, let's see what actually happens. If I create a new node here with malloc, and I get some other chunk of memory here, I will eventually want to point n at that, just as I did before, as the same line of code does the second time through my loop. If I want to change that garbage value to the number 2, I go to n, follow the arrow, set it equal to 2. Then I go to n, follow the arrow, set next equal to null. This still isn't a linked list because notice the 1 and the 2 are not yet connected, but the code I just wrote inside of my loop here proposes to update the currently created node n's next field to be that of list, and then update the list itself to point at this new node. So what this means concretely, even though we're crisscrossing some lines here, is the following. If my next step is going to be set list equal to n, as it was a moment ago, that's bad, because watch what happens. If I immediately set list equal to whatever n is, and n is pointing here, that's like doing this. And this is bad, as per the red on the screen. Why? This does not link the list together. Why? Yeah. Yeah, I've like lost track literally of the very first node. In computing speak, I have orphaned the very first node because no one is pointing at it anymore. And this is actually a really bad memory leak because if you have no variables pointing to that chunk of memory, you literally cannot free it later on in your code, so it's never going to be freed. And you'll just gradually leak more and more and more memory by something as simple as this. And so that's why I indeed deleted that line of code, and I propose now most recently in VS Code to do this. Take the new node, follow its arrow, and change its next field to be whatever the list itself is currently pointing at. So what does that mean? Go to n, follow the arrow, and update this box here to be whatever the value of list is. And here again, it's a little weird because I don't want to copy the whole list, but list, L-I-S-T, is just a variable containing a memory address, and that memory address is whatever the address of this first node is. So that's like saying this box should point to the same thing that list points at, which is like adding an arrow in memory this way. Now that's not the finished work. There's one last line of code that I did just add to VS Code where now it is safe to update list to equal the address of the new node because the new node is here pointing at this chunk of memory. So if I set list equal to that address, now we're linking things together. Takes a few steps, and in fact, let's get rid of the temporary memory that I created to make all of this happen. Now I'm creating a linked list. And if we were to go through this one more time around, same exact code inside of that for loop for the third and final time, I would then have this structure, for instance, in memory. Now, I've deliberately, artistically written it sort of left to right so it kind of flows in a pretty way, but technically the 3, the 2, the 1 could be all over in the computer's memory, but these arrows would just curve a lot and point to those locations. But I haven't quite built up the same list of numbers as before. I kind of screwed this up. What have I done wrong, it would seem here, vis-a-vis the array that contained these same numbers? Like, that code is correct. It links numbers together, but what have I built in memory that's a little different? Damn it, it's backwards, right? Like, it's 3, 2, 1. If I read it from left to right, which I should, because this is where the start of the list is, the so-called head of the list, and indeed 3 to 2 to 1. Now, technically, I could probably come up with some way of reversing that process, but these arrows literally point in only one direction. And because, in fact, what I've actually built is what computer scientists would call a singly linked list, whereby each node points to another node, but there's no way to go in the other direction. That would be what's called a doubly linked list, and I could do that. I could build rectangles or nodes in memory that have 3 locations, one of which points this way, the other of which points that way. Then I can go back and forth and solve that same problem. But at the moment, without some fancy code, I don't think I can print these numbers from left to right in exactly the same way. So I built this darn thing backwards, it would seem, with this code. So while the code itself is correct, it doesn't maintain the property that I wanted of keeping these things perhaps in order. So what's the implication then, or how do I actually go about recovering from this? Well, let's actually see how the list prints in practice. Let me focus on the slide here. Here's that same memory. Suppose that I give myself a temporary variable, we'll call it pointer for short, which is what a lot of programmers would do when using pointers, PTR. And if I created a variable in memory called pointer and I initialized it to the first element of the list, I could use printf and print it out. I could then follow that node's own arrow and effectively point at the second location and print its number out. Then I could update that arrow to point to the last location and print its number out. So this idea of having PTR, this variable, loop from left to right, is actually something I could translate pretty readily into code here. In fact, let me do that. In my VS Code here,
Not gonna lie, I don't quite understand the explaining part of that. I'm gonna need to either rewatch it or find other simpler, more way of like explaining that. Okay, I know get in is not, it doesn't exist. Okay, so it's not to null, but it's to list, and list is equals to n right now. Okay, how does this work? Okay, I'm gonna need to check this out again. This nodes here. So conceptually, we can imagine the process for getting linked list. Node list is declared, but its list is garbage value. It's this one, right? Because it just points to null. Or wait, don't list node. Okay, so we have a pointer list that is basically pointing to the empty, yeah, because we set it to null. It's the type def of the struct. Sorry, it's the type node. We use that because it has the value as well as the address. Initializes the head of the linked list, node and malloc. Okay. Okay, it's actually not that. It's not initializing the head of the linked list, but it's ready for numbers. What is that supposed to mean? Yeah, I don't get the memory for now. Okay. But it's basically creating this with empty value. Okay. Next, a node called n is allocated in the memory. So we want to start inputting those values. We do a for loop. We created a pointer n using malloc. Next, the number of node is assigned to the value 1. Okay, we couldn't do the get list, but it's okay. I forgot. Is that how we grep? Is that how we use grep? No. Never mind. I forgot the move command. Okay. Like how, what if I want to change it to the on top of directory? Oh, sorry, it's a move. Sorry. If you want to copy, what is the command? Okay, maybe the path was wrong. Okay. Okay, just the dot dot. Okay, sorry. It's been what if I want to copy? What if I want to copy? What if I want to make a copy? Ah, okay. So we can just do that. Okay, cp list. Did I just put the wrong? Ah, I just, okay, the learn C is just renaming it. Okay. Yeah. We do have a get int, right? Okay. So, so we have next the number of node is assigned to value 1. That is this one, right? And to number 1. Oh my god. Sandy, halo. Aku tetap coba cari di sini sih. Tetap cari di Jerman. I'm still looking in Germany, but not not getting any positive leads, to be honest.
And propose that time passes. Maybe there's some other code that I've written there. But what I really care about now is printing those numbers. So how can I do that? Well, I need to create sort of my, sort of foam finger in the computer's memory, which I'll call PTR. So I can do node star PTR, and I can set that equal initially to Well, how do I begin this? Let me go back to the diagram. I want PTR to point to
Bukannya, isn't it like 3 a.m. in Indo? Still looking. Ke kota apa Bang sekarang?
3 first, the very first node in the list. So in code, what should I set PTR to equal? How do I access the head of the list? I don't have too many options when it comes to variables in this program. What could I set PTR to equal? Well, there's only one variable in the computer's memory that technically points at anything at this point. So the answer is on line 12.
Oh, okay.
List, that's correct. So I could set PTR equal to list because just like
Bond?
this diagram, if
Oke. Lanjut master Bang atau work or in portfolio? Yes, I do. I have. It's in the I don't know if it's set up correctly or not. It is in the description, hopefully. Oh, yeah. It's supposed to be in the description, I think. It's at xyz, the cheapest domain that I could
I want
find.
PTR to start at the point of the to point at the start of the list. That does not mean that I want it to point to this thing. This is just a
It's super basic. It's nothing special, to be honest. It's literally just I think it's like 4 files, 4 or 5 files. No, actually it's a lot. Never mind. But yeah, no, actually yeah, this is more than one file. I forgot. Thank you. Although it's super basic and I don't know. I don't know if I want. I don't know if I wanna. I think I should update it because that is so sangat is so uninteresting.
I'm using to keep track of where the first node is. But again, if we were to take away these arrows as an abstraction, this just contains an address like OX something. So what I really want to do is put into the PTR variable that I just created the same OX something so that it's pointing at the first node in the list. So that's like saying
I did, but I failed the interviews. That's why I'm doing this again. I did, and I failed. That's why I'm like rewatching the CS50 to kind of learn the basic. Although using C again, and it's kind of like, even though I failed for like React, and the other one is for a product developer, so the tech stack was, I wasn't very, it was Java, so I don't know anything about Java, but and yeah, it's basically terrible, and I do not want to experience that. And again, that's why I'm trying to relearn the basic again and trying to actually make this work.
and this is the annoying
Hopefully.
pointers because they are variables, but they're really addresses to other variables, that kind of thing. So you kind of have to pause sometimes and think about, all right, what is it I'm actually moving around in the computer's memory? In this case, it's just the address.
Udah kerasa dulu gue gak dapet. I would say so. I think this is my interview rate. So I got. I'm just gonna ask ChatGPT. So I I applied to 300 and how much was it? I applied to 395 plus 178 and only get, I think I only did like 5 interviews. 5 interviews. 4 of them I failed. One ghosted. So yeah. Yeah, that's just 0.87%. Oh fuck. Okay. Oh my God. Okay. And it's not only just like developer job or like front end or web stuff, but also some of it is like content creation work as well as like video editing. So yeah, it's the 500 and 600 is application. It's not only for like engineering/dev job, but also some creative jobs and like content creation or editing as well. So that's even worse.
Of that first node in the linked list. All right, if I go back to VS Code here, the rest of the code is actually fairly straightforward, and we can use, for instance, a while loop. So while that pointer value...
CX Space, hello. Hello, so as the title says, I'm coding, or at least learning, to code such program until I get a job, a developer job, that is. And currently doing, yeah, currently relearning physics from CS50.
So while I still am pointing at valid memory and I have not reached the end of the list, go ahead and print out using printf, %i\n, and print out the current node's number field. So again, PTR, just per this diagram, is pointing at this node, and this node. So in code, what we're going to do is literally dereference PTR with the arrow operator, follow that arrow, get the number field, and print it out. The only bit of complexity now is inside of this while loop, how do I update the arrow to go from one node to the next? Well, this too is a little mind-bending at first, but what I really want PTR to equal the next time through the loop is to point at this node. Well, how do I do that? I think after one iteration, I can set PTR to be the exact same thing as the first node's next field. So if PTR is pointing at,
because yeah, okay.
PTR arrow next is the address I want.
Should another more soon? I want to know. Of course. I mean, I'm currently in Essen, and so yeah. Looking forward to meet you again next week, hopefully. I mean, safe. How's the flight and the preparation? Hello, welcome. You are?
Because it points to the second node. So even though this looks a little weird at first glance, this is the canonical way to sort of iterate through a linked list. I just want to set PTR now equal to whatever PTR is now and its next field. So this is just like following the arrow, following the arrow, following the arrow. And if after all of this, I open my terminal window and I do make list again, enter, there is going to be an error, which I promise I knew was coming, but how do I fix this? Undeclared function get int.
You need to include the CS50 library.
I didn't want to scanf and like complicate things unnecessarily today. I just wanted to get a simple integer to play this game. So I'm going to include CS50.h at the top, reopen my terminal window, rerun, make list,
hello,
enter.
welcome.
Now we're good. /list, and I'm going to manually do the exact same thing as I did with the array. 1, 2, 3, enter. Oh, it's backwards, but at least it is built up in memory, and we can indeed see.
If you make that video sound up like I can hear it properly. Oh, okay, wait. Let me make the volume bigger.
That what I have built is exactly this structure here.
There you
The
go.
upside, though, of
Is it
having
better?
built it backwards is actually arguably a little bit efficient. In fact, what I've actually done here leads us to kind of a discussion of like the running time of these linked lists. Like arrays were super fast because they were contiguous and we could search them from left to right in linear time, or per week 0 and 2, if we sorted the elements, we could even achieve logarithmic time, log of n, because we could do binary search again and again and again. But let's consider linked list. Here's kind of our cheat sheet of some common running times, but not all of the running times in the world. How much time does it take right now to search a linked list from left to right for some value? Big O of n. Why is that? Well, you have to start at the start of the list, the head of the list, and if you're looking for any value, whether it's sorted or not, worst case, you might have to go from left to right all the way to the end, aka the tail of the list in this case. So yes, big O of n exactly describes...
Okay, let me try to run this. Yeah, I'm still trying to understand the syntax. The arrow thing is blah, confusing it. Yes, okay. Thank you, Bang Sandy. Good luck to you too. Streaming in job hunting. That's crazy. Okay. Okay. Let's just follow the professor, and then here we have a node. We have a pointer list while doesn't equals. Because it is basically the TTR dot number, right? So it's basically just the address of TTR, but the value inside of that address, because pointer is a type of node, and inside of the node we have this number. It's basically grabbing that. Bro, if you just stream daily, you become a streamer. I'd love to do it daily, but sometimes I couldn't because, to be honest, I got a part-time job, but it's in a restaurant. So technically, I did get a job. But I didn't really specify the title of what type of job. But so I'm gonna refer it as like dev or any programming jobs. But yeah, so I couldn't really do it every single day because of that. But in the days that I don't have shift, I would try to work, or if I got home early or something like that. But the goal of doing this, you can make videos on what you learn. Oh yeah, actually, that is actually pretty funny. Okay, you know that is like actually correct. I should make a long form video about the things I'm learning. Huh. I'm gonna write it down. I think I made some. Do I make something? No. But I do have some Notion. It's not really the Notion database, it's the stuff. I have a lot of backlog in the scripting videos and like editing and everything. So, hello, Shubham Razi Bihari, welcome.
The running time of search. What about insertion? The process of adding a node, adding a node, adding a node. Here's where I actually did something arguably clever, even though it kind of backfired in the sense that things came out backwards. What's the running time, per this cheat sheet, of inserting a new node into the linked list as we've done it so far? It's not O of n. O of n would have implied that we're constantly going from left to right and adding it to the end, but I wasn't adding it to the end, I was adding it to the beginning, which means big O of
1.
It's actually big O of 1. because the beginning of the list is always perfectly accessible to me. It doesn't matter how long the list gets. If it has 3 elements or 300 elements, the start of the list is always right there in front of me via that list variable. Now, technically, it doesn't take literally 1 step. I think if I did the pointer, so I might have to use like 2 or 3 steps in total, but it's constant. And that's what big O of 1 means, constant time. And so, indeed, I can kind of see that here. If this is my list originally and the whole thing is empty, and I insert the number 3, that only took 1 step, really. Or that took, rather, a constant number of steps, whether it's 1 or 2 or 3, whatever. It wasn't n steps. How do I insert the 2? Well, my picture looked briefly like this. That 2 has no dependency on how long the list already is because I'm just prepending it to the list. And the number 3...
Damn, why is everybody having a Python exam? Are you guys in the same school? Like, I think Amut, and damn. What subject? Oh, really? Okay, wait, let me check. Let me check bit and tag. Let me check. What? You have 400 subscribe 400k? What are you using? Are you No, I mean like what type of Python subject? Quantum is coming? Oh, really? Wait, let me check. Do you have any courses that is free? Computer networks? Is it okay? Is it in English or okay? It's okay.
Press the bell icon and never miss a video on cybersecurity and technology.
You know what? In some of the days, I will learn PHP because I have enough of JavaScript. But yeah. Wait, yeah. Let me find the. This one. This video. I love this video so much.
The fastest way to master JavaScript, it's actually pretty simple. 1, just learn the syntax. Learn X and Y minutes is a great resource and to be able to like learn any new language really quickly. 2, just simply spend 1 decade building really complex apps in JavaScript and become a master of all the different ways you can build applications. And then 3, regret everything and just simply learn PHP like you should have 10 years ago.
I should have probably started with that. Yeah. What do you guys think? Should I just switch to PHP? Yeah, I mean, I don't understand Hindi. I can't speak Hindi, or I can't understand it. So I don't know if me watching it would be nice, or because I don't understand. I'm from Indonesia. Because I don't understand Hindi.
Appending it to the list. So even if this thing is getting longer and longer and longer, there's no reason for me to walk or search the thing from left to right. So the upside then of this algorithm thus far of prepending elements...
For Shubham, is that how you write it? Shubham Razi? What topics of Python do you have for the exam? Like, I mean, like, would it be OOP in Python? Would it be just normal regular general programming with Python? Would it be data structure, or would it be like I think previously someone mentioned like using SQL, querying database, or like CSV, manipulating data with Python? So like what type of subject are you what would be the subject of the exam, and which part of specific Python are you gonna be examined with?
Big O of n for searching, but big O of 1 inserting. And if I'm doing a lot of inserting into this data structure, like that is compelling, as constant time always is. The catch, though, of course, is that things end up backwards if I care about the order in which I insert them, and maybe I do, as per our discussions of stacks and queues, which are fundamentally separate from this topic. Now we're talking about low-level implementation details, but I might have accidentally now created a LIFO structure instead of a FIFO structure, which might indeed be germane. So how can I sort of work around this? Well, maybe I could do something a little differently instead. Instead of prepending, well, let me see how much effort it would be to actually do a maybe an appending to this list instead. So once I build the list with the first node, I ideally plop it here. Second node over there. Third node maybe over there. I can maintain sorted order, which is great if I do in fact care about a FIFO property, because now first one in could be the first one out because it's always readily accessible. But I think I just shot myself in the foot here. Let me quickly pull up some code for this. And let me propose that my code now might look a little different. Let me open up VS Code here. And in VS Code, let me go ahead and propose that if I want to append instead, that I go ahead and do this. Let me hide my terminal window. Let me scroll down to the bottom here.
OOP, right? Like, yeah. OOP, to be honest, I already already forgot a lot of stuff. So even I need to like relearn some OOP stuff. But as usual, I think it would be like, okay, the object. But yeah, in Python we have this one and using the self one, right? And then we have the inheritance, polymorphism, encapsulation. What is inner classes?
And I think what's going to have to change is this stuff here. I can't just blindly insert the new element at the start of the list. And that's really what was happening with these 2 lines of code here. So how do I do this? Well, it turns out the code's going to get a little more complicated as a result. First, I'm going to initialize my next field here to null, just to make sure that it's not a garbage value, as I originally did, but then decided, it's not necessary if I'm immediately prepending it to the list. But now I actually have to consider 2 scenarios. And this is where sort of building things in memory gets a little annoying, because you might have corner cases, things that don't happen all of the time, but might sometimes happen. And what's a potential corner case when building a data structure like this? Well, maybe at the very beginning of the process, there is no list, so you can't just blindly append it to something that doesn't exist. You have to kind of special case the start of the process. So what do I mean by that? Well, in code here, I might do this. If my list variable, which keeps track of the whole thing, equals null, as it will at the start of the story when no nodes are in the list, well, this is easy. I'm going to store the address of the new node I just created. So I'm going to put a comment to myself to make clear, if list is empty.
Good night.
Empty, I am going to do this special case here. But appending is indeed going to involve some kind of loop. So else, I'm going to go ahead and do this. And I'll add a comment here. If list has numbers already, the second case that I want to handle is going to look a little different. I'm going to iterate from left to right over this structure in the following way. And I won't dwell on this code because it's perhaps more detailed than I need right now. But one way I could do this.
How are things going? It is pretty cold, but I'm from Indonesia, but I'm currently in Germany.
Is as follows.
It is around 10 p.m.
For node star pointer equals list, pointer not equal to null, pointer equals pointer next. Now that's a mouthful, but we'll come back to what that means in just a moment. Inside of this loop, I'm going to say the following. If at end of list, I am going to, so if pointer next equals null, then I am going to assign the next field of this thing equal to n, and then I'm going to break out of this entirely. All right, so this is a mouthful, but what do I actually want to do here? Well, if this is my empty data structure initially, and I want to add 1, that's easy. I just set list equal to 1. But then things get more generalizable for the second, the third, the fourth, the fifth node, because as follows. If I want to insert this next node 2, what I really want to do is start at the beginning of the list, and a moment ago, look for the end of the list. And as soon as I find the end of the list, as indicated by this being null, okay, now I can append it. How do I insert the third element? Well, I start at the beginning of the list, I iterate through it, I look for the null element, and then I can append that to the end of the list. So even though this code, very admittedly, is probably the most complicated that we've seen thus far, it actually achieves that same idea, as per my comments. So if the list variable itself is null, there's no list already, that's a super easy case. Just set list equal to the address of this new node, done. The harder part is every other case where we're appending to the end of the list. Now here I'm using a for loop, which is a convention. I could use a while loop as I did for printing, but let's just think about what this does. This creates, like any for loop, a variable, in this case called pointer, and it sets it equal initially to the start of the list, because that's where I want my finger to point from left to right. Then I keep doing this so long as the pointer itself is not null. And then on every pass through this loop, just like with my while loop, I want to set pointer equal to pointer next. That's like moving my list span to point to the next node, to the next node, to the next node. And I want to do this so long as the pointer is not null. Because once it is null, then I've gone too far. So how do I do this? Here I am inside of that loop, and I'm asking, if I'm pointing at a node whose next field is null, that means I'm at the end of the list, because that's the one node initially, then the two node, and so forth. So if the thing I'm pointing at's next field is null, there's nothing more to go. So what do I want to do? I want to change that null value to be the address of the new node, and then I'm just going to hit break and break out of this whole loop because I'm done. So it's
Hello,
mouthful
welcome.
syntactically, even
And
though we're using all
yeah,
the same stuff we
in Indonesia, I'm from West Java.
saw last week, like stars here and now arrows here. But this is just asking the question, as I point from left to right, am I pointing at a null ending of the list? If so, just tack on one more node, please. And that's it. And again, if you're comfortable at least with the concept of what we're doing here, appending, that's really the current goal at hand. And in fact, what I can do now is let me go into VS Code here, and I can actually change that version of my printing to be very similar, if it's helpful to see one side by side. So in fact, if instead of using a while loop at the end of this code, as I did before to print this thing out, let me actually change this to be quite similar instead. Let me go in here and say for node star pointer equals list, pointer not equal to null, pointer equals pointer.
The pointer equals to null would mean that it's the end, right?
Next. And then inside of this loop, just as before, let's just print out %i\n, the number in the current field, semicolon, and then down here, heck, I'll return 0. So in other words, what I did with a for loop is identical conceptually to what I did with a while loop. If I undo, I'm hitting Control Z again and again and again. I'm just undoing all of this code. The exact same thing as this, but just as we saw in week 1, for loops tend to be a little more concise, fewer lines of code than the equivalent while loop. So that's all I'm doing here is rewriting this using
Lovely professional. Yeah. I'm watching this first because I want to understand. Because sometimes there are questions that I don't know, but then like, oh, he answered it, so that's why like, or maybe yeah, I could, but this part is a bit confusing, and I might need to rewatch it again some other days or like practicing it. But yeah, it is definitely very confusing. This PTR is like the I++. Okay. Right. Okay, this is the first, and then we can create new A. We can create it this. Open numbers. What programming? It is C programming language. And what would Lovely Professional? Is it this one? Ah, LPU. Oh wow, the building looks nice. Is there any, like, is it someone's name, the lovely part, or is it like actually the word lovely? Is it like based on somebody else's name? Is it based on certain things? That's why it's called the lovely.
using the same for loop syntax. Whew. Any questions on what we just did here? Even though I know this is complex. Yeah. A really good question. If list and if n are if list and n are addresses, then where are the names of these things being stored? The compiler is actually taking care of that for us. Inside of the program, long story short, there's a symbol table, and those symbols map to corresponding locations in memory. You don't have to worry about that in your own code. That's one of the things the compiler is doing for you. And in fact, the names of these variables at the end of the day don't even matter, but they help the compiler.
Yeah, I mean, like, yeah, I thought it was somebody else's name that has lovely name, because usually universities using somebody else's name, right? But that is actually an interesting name.
All of your usable memory is. Yes, that is correct. Let me rewind to where we built this here. So this is why I keep emphasizing, think about what the variables actually are in this world now of pointers. What list is the address of a node. What n is the address of a node. So when we say list equals n, that doesn't mean anything related to the names of these things. That means go into memory and grab this address and copy it over here as well, so that they are fundamentally pointing at the same thing. The names have nothing to do with it. But again, today I encourage you, when we're talking about addresses, think about what's actually inside the box. It's not just a number per se, it's an address. It's an address. A good question. All right, so let's clean up one other detail here. Let me propose, whoops, spoiler. Let me propose that we consider this question. So we've just built up a linked list now that is appending nodes to the list. Upside of which is that we're actually preserving that first in, first out property potentially, if we care about that, because it's 1, 2, 3 now instead of 3, 2, 1. However, have we made a dent in the running time? I don't think so, because if anything, it's gotten worse. No longer are we inserting in constant time. Now all of our appends require big O of n time, just like our searches, because we have to constantly search from left to right, search from left to right. Now admittedly, we could do a minor optimization. We could just have another variable that just always keeps track of the tail of the list, and that is a perfectly valid solution. It's going to cost us a little more memory, but that's valid. But in general, when you're appending something to a list and you're implementing the list as minimalistically as you can with just one pointer called list that points to the beginning of the thing, then arguably it is going to be big O of n. But if that matters is really a question for the problem you're trying to decide. But I think there's one thing we should still do before we move on past this code. Now I have a program that indeed builds a linked list by keeping everything in the same order in which we inserted it. However, I have not yet done anything about actually freeing the memory that I've actually been allocating all this time. So let me propose to the bottom of this program, before I return 0 and say I'm done successfully, let's just propose that some more time passes in the sense that maybe there's more code going on that's more interesting. But if and when I do want to free this linked list, it's actually fairly straightforward. I can specify that I want a temporary pointer called PTR again, for instance, set that equal to the start of the list. While that pointer is not equal to null, what I want to do is this. And this is where you can potentially get into trouble. I could free the current pointer, and then I can update pointer equals pointer arrow next. In other words, if I want to free these elements, I could simply iterate, I can simply iterate over all of these addresses from left to right, freeing the pointer and then updating it, freeing the pointer and then updating it. And that's how I move my finger from left to right. This is a problem though. It's subtle, but as soon as you have freed an address in memory, you may not touch it again. You can think of it as the operating system immediately might do something with it, and it's not yours to touch anymore. Therefore, on line 59 at the moment, it is not allowed for me to go to that address, check the next value, and actually update pointer accordingly. It's too late for that, because in line 58, I already said operating system, I'm done with PTR, the address therein. But there is a simple solution, even though it might feel like things are kind of escalating. If I'm not allowed to touch pointer after I have freed it, but I really do need that next address, that's fine. You can simply create another pointer called next, for instance, set it equal proactively to the next field, then free pointer as you intend, but don't touch pointer again, just touch the temporary variable that you created. So when you free pointer, free is not super powerful, whereby it's just going to iterate over the entire data structure you've created. It is simply going to undo one of your mallocs. Each time you call it, undo one, undo one. So if you want to undo all of them, that's up to you and me with our while loop here to iterate from left to right, freeing the node, then moving on to the next, freeing the node, move on to the next, until we hit the end of the list. And we don't need to go any further. So there's still one bug, and I'm going to wave my hands at this one, but up here, recall, we did use malloc before, and it might have been the case that this very first call to malloc failed, in which case, okay, fine, we return 1 and we're all done. But if you imagine in your mind, what if the first call to malloc succeeds, the second one succeeds, and the third one fails? You can't just abort the program on line 20 and be like, oh, well, I'm out of memory at this point. Technically, before you return, I should free any memory already mallocked. And I'm not going to bother doing this now because this is going to add undue complexity, but that's the sort of subtlety that starts to get involved when it comes to memory and memory management. And in fact, among the motivations in a couple of weeks' time when we transition to another language called Python is that if like you're just getting confused by this, you're zoning out, it's getting way too complex. Like a lot of people in the world feel that way. And it's so easy to write buggy code. It's so easy to write dangerous code in C that among the reasons for other languages like Python and JavaScript and the like to exist is that we can abstract away all of this memory stuff that you and I only have to struggle with for one more week. But even these details will still be there, but someone else will have done that heavy lifting. And you'll just use languages that take care of all of this complexity for you. So hang in there for this 1 week when we do sort of cap things off with these concepts, but rest assured that we'll soon be able to abstract those away as well. Any questions then on what we've just done?
I think I'm gonna stop from the linked list and trying to understand this, because not gonna lie, this is very fucking confusing, and I was quite disturbed a lot. There was other things going on at the house, so I'm not 100% focused, but yeah, let's just finish the chapter, try to do it again, probably find another.
All right, rather than type this one out, I'm going to show one final version of this linked list implementation that's actually going to be a little smarter still. So if you imagine a scenario in which you don't really care about, you don't want the thing reversed, but you don't really care about the order in which things were inserted. What you really care about is sorted order, so that no matter what order you insert integers in, you want them to be sorted from smallest to largest. And you want the code to just figure out where to insert them, at the beginning or at the end, or heck, maybe even in the middle. So for instance, if we have a linked list that starts with the number 2, I want it to look like this in memory. If though I then insert the number 1, I want it to go before the number 2 so that the thing is kept
Node list, yeah, for and I. Bro, explain what you're writing. Okay, let me try. Okay, first we need to write the standard library so that we can use a lot of the other function. For example, the stdio is for, actually don't, stdio is just like it's usually always standard input output, because we're gonna print something using like the printf. We have the stdlib to access the malloc function. And then we have CS50 local. So basically the CS50 have their own sort of like C library with a lot of the helpful function that is abstracting a lot of the complexities to make it just easier. Like for example, this getIn function basically gonna ask the user, us, or whoever run the program later, to input some number, so input some integers. And yeah, since I do not run like the same thing that the professor run and like the other CS50 student working on, they have their own like sandbox. They have their own like development environment. I think they're using GitHub or the VS Code. I forgot, but it's already set up. But for me, since I'm usually doing it locally on Ubuntu, I created this CS50 local file as well as the header file so that I could basically use the similar functionality of the getIn or getString or any other CS50 function. Yeah, so yeah, that's that. And then here, if I'm not mistaken, this is created the list at the first. It is created the list the first time, like this empty pointer that points to null, just to. Why do we create the list again? Forgot. We can imagine the process of creating a linked list. First node list is declared, but it is a garbage value. Next, a node called n is allocated in memory. Okay. Maybe it's just to be used as the pointer, right? Next, the code called n. So here in this for loop, since we want to, so yeah, this is, how can you use VS Code? Bro, you can use VS Code to make it easy work. Yeah, I do. What's your age and give some life lesson? Bro, I'm 23. I think the life lesson that I've been learning, especially after 137 days of doing this, is that it is sometimes okay to breathe and take a break when you can't really handle things anymore, especially like, I don't know your situation, I don't know your circumstances, I don't know what is happening in your life, but basically, as much as you really want to always not quit, as much as always you want to grind and just keep pushing through and going through, you will need some rest at least. Yeah, I'm 23. Whether you do like, okay, 1 day break from learning, from coding or anything, but you still have to give your brain, your body, your mind some rest. So when I first started this like streaming, for the first like 100 days, I almost do it sequentially, like back to back. I'm using the professor word, like continuously. I was doing it almost every single day. I might miss like 1 or 2, but yeah, and at the time I was free because I just finished my thesis and I was looking for work and everything, and just like, but then after the 100 days, after all the hundreds of work rejection, not getting any interviews, getting rejected in the interviews, I just take a break, you know? So I guess for me to anyone is that you still need to grind, you still need to work hard, you still need to have some consistency and yeah, work hard, basically just putting in the work every single day. But there are some times where if you really like lost your motivation, or where you hit like, I don't want to be some weird ass psychology pseudo science thing, but if some of the symptoms is similar to like a depression or almost leading to a depression, I think you really need to take a break at least. So for me, to everyone, is that keep grinding, but also have some rest, because your brains really need it sometimes, I guess. Okay, continue.
Sorted. If I then insert the number 4, I want that to
I am 23, but what do you want me to say? You want to see my ID? It's already in the dark web anyways, because the Indonesian government leaked it. So, sorry. Are you expecting me to be younger, or are you expecting me to be older? Man. Okay. Okay, so this, so yeah, allocating the memory. So it's, yeah, that creating, like saving a part of the memory using malloc with the size of the type node. Yeah, nice, right? Like, programming is hard. Even like with the help of AI and everything, you still need to understand the basics. You still need to like know how to run it, or like how it works. Maybe with the help of AI, it's like you don't really need to memorize every bit of syntax and everything, but at least like the algorithm, the data structure, and everything. And that's why I think I'm trying to relearning it again, because I've been using AI too much. And not gonna lie, it is making me dumb. So here I am trying to relearning it again, so that I could still use AI, but a bit more efficiently, a bit more better, and that I didn't use, like, it's not 100% just vibe coding, you know? Like, at least I know, like, I can instruct the AI better. Okay, sorry, back to this. So we have that. Yeah, next, the number in node 1 is assigned to value 1. This is, we're gonna prompt this in the terminal, and we're gonna grab us. Next, this next field is assigned to null. Yeah. Yeah, I mean, like, even like setting up Python on your local computer is a bit difficult. When I like first learned about it, oh, you have to download this Python. Oh, but then you need to add this to path. Oh, but there's I'm using this, I'm using that. There's one time where I use Conda, and then there's other version where, okay, the Python in the path is set up to the wrong version. You have multiple Python and it doesn't work. So I think even as small as understanding like the documentation, even understanding like programming languages documentation needs a little bit of knowledge, or like, how would I say, like, you still need some knowledge, you know? It's not just like, oh, it's documentation. Like, you really like, when I was doing my thesis, there was no documentation at all on the previous project that I need to continue. The code was messy. It's like no file naming was atrocious. Like, there are two essentially the same thing, but one is 1.2, the other one is like 1.2.1, which is the exact. It's just like 2030. Damn. Okay, I guess, yeah, it's fine. Maybe because I haven't shaved and I look old, but I just finished my bachelor, so yeah. Exactly. Yeah, yeah.
Be appended so it retains sorted order. And lastly,
Yeah, true. I mean, I think that's the benefit of India. They have like tutorial for everything, and it's like a huge respects I have for a lot of like the Indian creators and engineers and teachers that posted the video. Even when I was doing the electrical engineering, I learned a lot, because it's only the Indian people that have a tutorial for that specific subject. Even like some questions, or like uh some subject that is, yeah, I couldn't really find, but then, okay, we have this Indian guy explaining it, and it was like, oh my god, damn, that's cool. It's just because I have a long hair, man. I didn't really, okay, so basically, during, I think it was like the end of COVID or something, like I finished, or like it was early uni, right? The reason I lengthened my hair was because of this. Yeah, 3 years ago. You can watch this video, I'll link it below, of why I didn't cut my hair, basically. And so, in this video, which is 2 months ago, I got back from Germany and I didn't really cut my hair for almost for 1.5. That's why it's also long because I don't really want to cut my hair here because it's quite expensive. So yeah, that's why. That's why I have long hair. And I just
If I
really
insert 3, I want that one
don't
inserted in the
like
middle.
to cut
And this
them
is
at
one
the
that I'm
time.
going to sort of pull out of the oven already made, because this is where code just gets to be a pain in the neck. Why? Because my God, there's so many different cases to consider. If I rewind here, there's the first case where the list is empty, and thankfully that's actually pretty easy. Just plop it at the beginning of the list. Prepending, also relatively easy. We saw that before. I can just prepend it to the start of the list. Appending's not that hard, but now I'm doing 3 things, so I'm sort of combining all of these past examples into one so I can append it to the end of the list. The one piece of code we haven't written yet is how do I deal with like inserting the 3 in between the 2 and the 4 without orphaning the 4, so to speak. Well, let me just reveal how we would do this, even though
Oh my god, a tutorial on how to escape Indonesia? Man. I started learning Python for 7 days ago, so you can find my repo. Okay, cool. I don't know if Alphabet is actually a good way, but man, if there's a way for you to find any scholarship to any country outside of Indonesia, I think you should give it a try. Find some random European country that have like less popularity, where you would have like less competition. Do like an exchange or like master a or with scholarship in like any Balkan countries or like uh any Eastern European country. Okay, maybe, or I don't know. Um, or maybe try to find work in the Gulf countries because the Gulf countries are really importing a lot of talents right now. They have all the oil money and they've been finding ways to not use that oil money anymore, right? Like they want to diversify. So even I'm currently looking for work in the Gulf countries as well. Yeah, man. Oh my God. I forgot the was it Nvidia or is it AMD that wants to make chips factory, but then like Indonesia was like, fuck. The it was supposed to be a democracy, but it feels like it. Like the injustice and the unfairness and the like inequality gap is too wide for the people. Gulf countries like yeah, like UAE, or like Kuwait, Oman, maybe Qatar, maybe. Because I mean, they have currently all of the oil money, and you know, they want to diversify out of that oil, right? They go into tech, they go into other businesses, they go into tourism. So there has to be a lot of opportunities there, and not gonna lie, I've been looking for work there as well. I see a video where Sri Lankan person go to Indonesia by plane, but Indonesia security ended beside work for airline takes dowry to visit Indonesia. I don't know what that always dowry by a bride to her husband, huh? Isn't this for marriage? Is the Sri Lankan person asking some Indonesian
You yourselves
for
will feel strict-
marriage? Yeah, exactly. Like, yeah, that is totally understandable why they do not want to do that. Yeah, or Dubai. I mean, like a lot of people really said that the taxes, there's no like income tax, right? So I don't know about that part. Oh my god, we have 65K views. Nice. Awesome. Sorry. Okay, I'm gonna finish this. And after that, I'm gonna go. Oops. Append link list. Oh, this one is the okay. Yeah, I forgot. This one you could place number six. Yeah, yeah. This one is the one that uh gonna print it first in first out. Right? Yeah. No, I still don't get anything. I only have like 700 subscribers. Oh, seven. Oh my God, we're almost 777. I haven't reached the threshold yet to get any revenue from YouTube, so no, but currently I didn't receive any YouTube money yet. So at least that's the goal. At least it was my goal for this year, but apparently I didn't reach it. But hopefully by next year, yeah. Hopefully by next year we could get some YouTube money, get monetized, grab some of that Google money.
Have to leverage this in your own code. Let me go in a moment back to VS Code, and what I'm going to open up here is another version that already has some comments in place just to help guide us. So it's almost the same from the start, whereby in main, I initialize list to equal null. I then, in my loop, am going to proceed to build a list of size 3, just for the sake of discussion. I have the same code as before, whereby I malloc one of those nodes, make sure that it's not null before proceeding to get a number from the user, and then proactively initializing the next field to be null also, so there's no garbage values in this world. But here is the beginning of those several cases that we just saw pictorially on the screen. If the list is empty, easy peasy.
Yeah, but I haven't reached the threshold yet, because I think it's because I don't know yet. That's oh, okay. YouTube live streaming watch time does count toward monetization, but only if the stream is archived and made public as video on demand. Okay. So live stream, not for 0 hours. Both the live viewing time and the subsequent viewing time to okay. So actually it does? Okay, I thought okay. So guys, if you guys stay here for longer, I could reach the threshold, so thank you so much. But okay. Based on your content, audience engagement, streaming consistency, YouTube live streaming, watch hours, count towards your total channel watch time in the real time, and the platform algorithm often gives live content preferential treatment. Recommendation notification. However, success depends on a factor like stream quality, timing, audience interaction. There's a website, Best to Learn Code, by the way. Which one? Tell me. Tell us. Watch hours on equal action. Counts live stream, watch hours, regular video with one result. The metrics accumulate in real time during your broadcast. Every minute the viewer spends watching your live streams immediately contributes. Ooh, thank you guys. Thank you guys so much for tuning in. If you have 50 viewers watching for 30 minutes, you'll accumulate 25. Okay. I think I need 230 more subscribers, but the watch time, I still need 300 more. Oh no, and I still need like almost 1,300 more. So thank you guys for tuning in and watching. You guys could like just watch the video and leave it on at night if you guys want to help me. YouTube, please don't ban. But yeah, thank you for the YouTube algorithm for pushing this video to every one of you. And yeah, I hope I can publish a video. I already edit them. I just need a couple more footage, and I'm gonna submit them. I'm gonna publish them.
Else if, why? Well, if the number I'm trying to insert belongs at the beginning of the list, that is, if I want to prepend this thing, okay, I can steal some code from earlier, update this node's next field to be whatever the current list is pointing at, and then change the list to be this new node. So that's the same logic as before, whereby I want to prepend a node. So this is like starting with just the number 2. I notice that, oh shoot, 1 is less than 2, so I want to put the 1 there, aka prepend. All right, there's another else here. And inside of this else is actually a loop with its own conditional, and this is again why I'm not doing this one live. So else, it's got to be at the end of the list, or it's going to be in the middle somewhere, depending on what number is inserted. So let's start a for loop whereby we iterate over this whole existing list. This one's actually pretty easy.
No, we need 1,000. This one is, the other one is different. We need 1,000. So, but don't make bot account, guys, please. I don't want to get banned. I want to do this organically, This one is only for like the memberships, but I don't really feel comfortable of you guys paying to join a membership but don't really have any benefits. So I'm not sure what type of like if you guys join my membership, I have to have some stuff that I could like offer. I don't want it to be just like, oh yeah, support me, but like yeah, like I'd like it for any viewer to have. Okay, man. Good luck. Have a great rest. The analytics has been okay, surprisingly. But yeah, I think this is because I didn't do any streaming for a week, almost a week. That's why it's a bit flat. But yeah, we got 100 hour, I think, for the past 30 days with almost 2K views. Nice. Oh, this one has okay. The average duration is only 2 minutes. I guess because more people decides to only watch a few seconds and get out, but it's totally okay. It's fine.
If we have reached the end of the list, as would be indicated by finding a next pointer equaling null, okay, this one too is fairly straightforward. Then change the next field to be the address of this new node, and then break out of this mess altogether, because we are done. This is like in our picture here, having 1 and 2 in place, and realizing, oh, 4 is bigger than 2 and 1, so it should be appended to the end of the list. It's the middle case that's kind of a headache, and that's the final flourish here. If I'm in the middle of the list, what do I want to do? Well, here I'm checking this logically. If the new node's number is less than the next node's number, so I kind of have to look ahead to realize, okay, I found my location in memory. I want to change the.
Yeah, see, even like the membership like goes to YouTube like that. So if you have to. Like Google, you have how much Google have? You have 95 billion in cash. Just give me half a billion, bro. Like they have this much. You don't need the 30% cut. Yeah, but that's the thing. Like I don't know what to offer. Yeah, but you know, I don't feel comfortable if you guys paid for a membership, but then you got nothing in return. Like I want to have something in return as well, you know? I like it's just you're spending money here. Like it's serious. Even though it's probably like only like $1 or $2 or euros, but still it's money. Like I don't want to give some yeah, I just want to give something in return back, you know, and I don't know what it is because as of right now, my content has been random, mostly tech, mostly videos, but also a little bit of myself. So, especially with this live streaming of learning.
The new node's next field to point at the current node's next field. That's like, in this picture here, updating the 3 to point at the 4. And then in code, update the current node's next field to point at n. That's like updating the 2 to point at the 3. And then, thankfully, break, I can get out of this mess again because I've handled the fourth and final situation. So again, with time, with comfort, with practice, like you too could like write code like this, but it really speaks to the complexity of trying to build up a fairly sophisticated data structure correctly in a way that uses all of these building blocks, but doesn't run afoul of leaking memory, orphaning memory, and this is why memory is just hard, because you have to worry about all of these little details. Questions then on any of these particulars up until now? Okay, I'm happy to say that everything here on out is going to be much more conceptual and much less code-oriented, but in the meantime, we have some delicious Halloween candy, and we'll see you in 10.
Okay, I'm gonna stop here, and I think for the next stream, either tomorrow or in 2 days or any other days I'm gonna practice with pointers like one more stream, practice, and then continue with the other data structures, and then I'm going with DSA with JavaScript. So yeah, because that was like my main goal was to be better at JavaScript, so probably focusing on that compared to C. But working with C again and relearning memories, handling actual memorings, like, you know, like it really makes me appreciate all of the garbage collected languages. But I can understand why it's a good thing to learn this as the foundation. Make a gaming channel. I don't have time to. No, that's just an excuse. I mean, I could just give them like edit Like I could edit them, yes, but I don't know what to play. I am currently living in a VG, in like a shared apartment. Okay, I guess that's it for today. Let's try the sorted linked list. Yeah, let's try the sorted linked list. Oh, we already have the file. Never mind. Good luck for the final week. Elon Musk or Mr. Beast. Let's put an aim into that, yeah? I'd love to help people, I guess, I would say. I think that really is a nice usage of free will, helping people. Ah, okay. This syntax is just a shorter version of this, right? Just a much or this or that. Okay, never. But I'm gonna follow the professor's code. Thank you, man. Our honor video. Hey, who knows, right? Probably Jensen Huang would like give his wealth randomly, and I got chosen. That would be pretty cool. I would probably focus, or at least like split. Like, okay, we're gonna make some GPUs for gamers again now, not just for all the AI company, you know, because man, imagine the gamers, bro. We need the gamers. Hello? Bro, there is no super chat or I pay for it. Oh, what? Is you doing a great job. Look here, bro, read comment. Yo, what's up? Bro, there is no super chat or I pay $50. What do you mean? You want to pay me 50? Super, this one, right? Yeah, but yeah, that's the thing. I need 300 more watch hour. Sorry. I still need like 300 more watch hour to for like the super chat and everything. But join the Discord, please. Like, so I think I'll try to be more active there because thank you Alfie for setting it up. But yeah, I'll try to use it more often. I'll try to read there and be more active there because sharing the videos, sharing the live, or maybe some learning progress as well there. So yeah, I mean, like even other people could just like share their learning, share their tips and tricks and everyone. So why not? Cool. Okay. What was it again that I want to do? Oh, here, the sorted one. Thank you so much, man. That really means a lot. That really means a lot. Thank you so much. Okay, I'll try to get the 300 hours. I don't know if I could do it this week. I mean, like, okay, let's just go to ChatGPT first to help me calculate it quick. Cause okay, let's just say I upload an 8 or 7 minute videos. So in order to get 1 hour, I need 10 viewers. So if I could get um I need 50k of viewers on that video to get 300 hours. Okay. I have an let me confirm. I have an 8 minute YouTube videos and need 300 hours to get into the YouTube monetization program. How many viewers I should get from that single video? Like around like probably 40 or 50. Oh, really? Okay, that's actually not that bad. Huh. Okay, I can actually, okay. I'll try to finish the video that I have been editing this week. And if it's good, if we could reach at least like 3,000 or like 2,000, we would get the 300 hours and then we can open super chat. So okay, I'll try to finish that. Okay. Okay, I guess let's try this code and see if it compiles. Let's do 1, 3, 4. Oh shit, I forgot. We need Oh hell no, man. Okay, I'm not that greedy, man. Like, as much as I'm looking for work and everything, but that's just too much, man. Okay, at maximum it's probably gonna be like two euros, man. I don't want to rip you guys off or something. Okay, uh, okay, I'm gonna learn about all those things, but okay, we make it 4, so let's compile it again. Let's do 2, 1, 4, 3. It's gonna be, oh my god, that is so cool. Okay, it works. Okay, it works. So that's nice, that's cool. Okay. I guess that's it for today. Thank you very much for watching. I hope everyone... Oh my god, hello. Shitich Kaushik. Sorry, I was about to end. There's one great because I want to be your first member, lol. Oh my god. Okay. Oh my god. Okay. I'm gonna research on like what are like the benefits that I could give for the members, because I don't know, man. Like I'm just maybe if okay. How should we do it? Yeah. Like if you remember, you could like hire me as your editor, or I'll help you make applications, something like that, but you get discount. Using GCS compile hurt me, bro. What do you suggest? Makefile? The thing is, I don't know how to use Makefile yet, but I'm using the GCC because I don't know what other ways to do it. Maybe Makefile, right? I'm currently actually preparing for any developer role at this point, but currently for the past few weeks I've been just practicing data structures and algorithm in CS50 with C, so kind of quite the opposite of the roles that I want to have, actually, if it's more like a front end or web role. But yeah, it is what it is, I guess. Okay, I appreciate everyone. I'm sorry for the one that's just joined, but it's almost 3 hours now, and I'm already tired and I need to go to bed. And I appreciate everyone. Thank you so much for the support that you guys in Discord ask when will I go live. That really makes me like, I don't know, maybe a little bit proud. Like, okay, there is actually someone that wants to watch me. And even CX Space that want to be my first member when I am able to some monetization. So thank you so much, guys. That really means a lot. At the beginning of the stream, like the very, very early days of the stream, I jokingly said that I hope when this channel became serious, I will be like a... no, that's a terrible joke. I don't think that's like a... I'm jokingly said, oh, I'm gonna run for the government or something, but it's joking, man. I don't want to be part of the government yet. But yeah, sorry. Okay, sorry. That's the tired talking. Okay, I guess that's it for today. Thank you very much for watching. I hope everyone have a great day, night, and afternoon, or whatever time zone you are in. And yeah, I hope everyone that is also looking for a job, everyone that is currently doing their exam, hopefully you guys can do it, can pass. And yeah, I need to clean my room. If you guys can see, that's my laundry, and it's been hanging for a week, and I need to put it in the trunk. Okay, see you tomorrow, if not tomorrow, in 2 days, or any other days that I could stream. So bye bye.